Login accepted.
The- Thank you. In the library, room 1814 or building 15. Yeah, come in your pajama attire. Most importantly, free food. You could RSVP at the QR code or the shortened URL. Another event is the Swift Star Wars Social this Friday. Okay. After the workshop, scheduled to start around 6 p.m. So if you want to test your Star Wars knowledge through a Jeopardy themed trivia night, head on down, and also free food. Okay, to our calendar. So today we're currently here, November 19th. Thank you for whoever competed in the RVB over this weekend. Hope you had fun. Okay. So I am Maxwell or Max. I'm a fourth year CIS student. I'm also the vice president of operations here at Swift. I've been on the CPTC team for the past 2 years, and I'm on the CCDC team for this current year as well.
And I'm Natalie Tran. I'm a second year CS student. I'm Swift's alumni coordinator, and I'm currently on this year's CCDC team.
All right, so for just some table of contents for this meeting here, I'm going to be quickly going over what is AWS, and then we're going to dive deeper into four key services that they offer in order from IAM, EC2s, S3s, and then finally Lambdas. So first off, what exactly is AWS? AWS, or Amazon Web Services, is the most used cloud provider with over a third of the market share of cloud providers. To give us a little bit of context, Azure, the next biggest cloud provider, has about 20% market share. Similar to other cloud providers, it serves as a pay-as-you-go model or pay for what you use. AWS ships with over 200 fully featured services. These services can be mainly categorized into compute, network, and container. But obviously, all these services can't fall into these three categories. For example, some of these services range all the way from quantum computing, satellites, or robotics. Um, because of the pay-as-you-go model and the wide range of services, uh, AWS is used by over 1 million businesses around the world. A few examples are Cal Poly Pomona, Netflix, Adobe, the NHL, NFL, and obviously a lot more. So when it comes with interacting with AWS, there are two main ways. The first is the console, or basically an interactive web interface where you sign into and you get to see all the services and you get to use nice wizards or setups that give you step-by-step instructions on what to do. And then there's the command line interface, which is uh, kind of a lot more. It's just on your own. You have to do each part or each step kind of just obviously just through the command line. Um, you don't always have the luxury of using the console. So that's why it's important to bring up the CLI. And we're actually going to be using the CLI a little bit in the workshop this Friday. Okay, so the first service that we're going to go over is IAM, which is Identity Access Management. This is also my statement that the old 3D Minecraft built logos are better than the new ones. Okay, so IAM permissions or IAM in general can be quite confusing. So I'm just going to kind of go layer by layer. So starting at the bottom layer, we have permissions. These are the primary access control methods used for AWS services. So each AWS service will have a handful, well, actually, well more than a handful of permissions to control what users or other services have when it comes to accessing or editing something that a service offers. So for those over 200 services, there is a total, as of the creation of these slides, 17,435 different permissions. Obviously, no one's going to remember all those. If you want to look at the graph on the right, it kind of breaks it down. So over half of these permissions are just to control or write access over these services. So to use these permissions, we put them in policies. So if you look on the left, there's a pretty simple IAM policy that allows anyone to access the contents of an S3 bucket, which we'll cover a little bit more. But if you want to look on the left, starting at the top, the version, you might think that this is the version of your own policy that you created, but this is actually AWS IAM's policy version itself, hence the 2012 date, which is actually the most modern version of an IAM policy. So that's pretty much going to be standard wherever. And then if we look into the statement, we see the SID or the statement ID. This is just pretty much the string identifier name, so you can name it whatever you want. In this case, I named it public access, as that is what it does. Moving down, we see the effect. Now we can either allow or deny. And then who or what are we allowing or denying? That is the principal. So you can make the principal a certain user or a student or certain resource. In this case, we just have it as a star or an asterisk, which acts as a wild card. So this is saying just whatever, apply to anyone. And then the actions that we are either allowing or denying are the IAM permissions that we just covered. So in this case, we have S3 list object and get object, which are the two permissions needed to list and download an object from an S3 bucket. Then lastly, what is the resource that all these apply to? So in this case, resources are identified by their ARN or Amazon resource name. And this is basically just a more readable identifier. So in this case, it is the S3 bucket Marine Monopolies storage. Okay, so how do we actually apply these policies that we create? There are two main ways. The first one being inline. So these policies are mostly created for one single resource. They're directly in line with that resource. So whenever that resource is deleted, the policy also goes away with it. As you could probably imagine, this isn't great for like giant businesses who have a bunch of different instances or resources. It could get quite confusing. So this is where attached policies come in. These policies are essentially stored in your AWS account, and you can attach them to resources. And when the main policy is edited, all those changes spread out through anything that it is attached to. Okay, so now that we have the policies or the inline and attached policies, what do we actually apply them to? So first off, starting with users. More specifically, IAM users. This is not to be confused with your standard AWS account or AWS users, which is the account that you actually like sign up with your email with or put your credit card in. IAM users act as more a logical solution. So let's say you have an employee in the accounting department, you would make them a specific IAM user. And then moving on to groups, your pretty much standard group, how it would work in any other infrastructure, just an organizational unit for users. So let's say, going off my last example, if you have a bunch of users in the accounting department, you would make an accounting group and then put them all in that group. All those permissions would seep down to them. And then lastly, roles. Roles are probably the most unique, um, as it doesn't really have a similar comparison in other infrastructures. But basically, the best description would be temporary permissions. So these roles, you're going to be applying them to instances, or actually users could also use them, which is quite confusing. But when I say temporary permissions, um, a let's say for an example, an EC2 instance, which we'll also get to in a bit, it could temporarily take the credentials and then use and then use those permissions to, let's say, gather something else from another service. So this might sound a little abstract, but you'll understand it in a bit. Oh yeah, so basically there's just a bunch of different ways to give users or really anything access in an AWS environment.
And now we'll be going into another service, which is the EC2 or Elastic Compute Cloud. So here's a general overview of an EC2, which is AWS's computing service, and it is able to autoscale based on the demand that you want. It essentially provides VMs that are hosted on the cloud, and those VMs are called instances. They're pre-configured with an OS and a few software requirements that you'll need. In the image on the right, you see that there's an instance inside of a security group, and that security group acts as a virtual firewall. That's all hosted inside of a VPC or a virtual private cloud, which can be described as a virtual cloud inside of the cloud. And that's kind of similar to how a virtual machine is like a virtual computer inside of a physical computer. And here are some use cases of EC2s. They're great for development and testing environments. They're also great for hosting applications that are on the cloud, and they can be used for disaster recovery in case something ever happens. They can also be used for high performance computing, such as CPU intensive tasks. And EC2s don't really have vulnerabilities, but there are vulnerabilities that can affect or exist from vulnerable code in EC2s. And one of those is the server-side request forgery, or SSRF. And this is where user inputs are able to be manipulated to make unauthorized requests into an internal server's resources. So for example, if you have a URL and you did like /administrator, you might be able to access the administrator panel or those resources that you should not be able to access. And this is particularly dangerous on the cloud because you're able to go into the metadata endpoint and get AWS credentials. And the next one we have is remote code execution, or RCE. And this is where a vulnerability is exploited and you're able to execute commands that way, which could lead to attackers gaining access to a network. So for example, this box has a cat wrapper script, which should just be the cat command, so it will read text from a file. But if you edit that, or if you write a script with the same name, you might be able to append something like a semicolon and a command after it. So in the box below, you'll see that the cat wrapper script is running with the list command appended. So you see the text from the text file, and it also lists some files below.
All right, so moving on to the next service are S3s, or simple storage service. So S3s are kind of marketed as a way of unlimited storage. Technically, there is a limit. I believe it's per object, a 5 TB maximum. Um, Hopefully, you don't have too many things that are 5 TB in a single file. But um, yeah, like I said, it's an object storage solution in the cloud. So basically, you don't have to pay for any of the hard drives or something compared to like a physical solution. Instead, AWS charges based on the amount of objects that are stored, the size of them, and most importantly, the amount of requests that are made to the objects. And then this is just a little screenshot example of what it looks like or what a bucket looks like using the web console. So buckets can be used in a variety of different ways. Um, the most yeah, so they could be used in many different ways, mostly dependent on how frequently they're accessed and the information inside of them more specifically. So for example, if we look all the way on the left, you get the S3 standard, which is the default. Um, as you look at the description underneath, it's general purpose storage for frequently accessed data. And then if we go all the way over to the right, we also get introduced to the very fun naming conventions that are used in AWS, such as S3 Glacier Deep Archive. Um, and then, so if we look at the description there, it's basically just used to store archive data or data that is just very infrequently accessed. Um, all these different frameworks for buckets are mainly just used um, to kind of min-max the money that you spend. So obviously, if you're using an S3 bucket for archive data, but you're using just the S3 standard framework, you're kind of just costing yourself more money. So Amazon kind of gives you these little frameworks. Obviously, there's many more of them. I'm not going to go through each one of them, but you could kind of get an idea of how flexible these services really are. Oh yeah, so adding on to just how flexible these are, you could actually host an entire static website inside of an S3 bucket. Once again, there's a screenshot on the right of just how easy it is. You just press one button, enable, and then you could kind of just walk through the steps really easily, and you could host your own website. So kind of piggybacking off what Natalie said on how these services aren't really vulnerable inherently. It is more just how they are configured, or in this case, misconfigured. So the first vulnerability would be misconfigured permissions, which again is calling back to the IAM permissions that we went over earlier. Just for an example, let's say a company is using an S3 bucket to store a bunch of credit card data or customer information, PII, whatever. And then they update their permissions to accidentally allow any user to read that data. Obviously, that's pretty important and not ideal. Kind of similar, but in a different fashion, is sensitive data upload. So let's say, for an example, a company has a public S3 bucket, which they use to serve general information to their users, but then one day accidentally upload sensitive data such as customer PII to that, and then everyone can see it. Um, yeah, so these two are kind of similar, but just in two different ways.
And now, and now we'll be talking about the third or fourth server, which is Lambda. And here's another overview. So Lambda is a function as a service. So users are able to develop, test, and manage application functions without having to worry too much about infrastructure. It's AWS's event-driven serverless computing service. And by event-driven, that means it gets triggered after a specific event. and the Lambda functions are running after that event. And the term serverless is a little bit misguiding. It doesn't mean that there is no server. It just means you don't need to manage a server. And on the bottom is an image of how a Lambda function should work. So for instance, you can take a picture and that picture gets uploaded into an S3 bucket, which is the event that triggers the Lambda function. So then it will resize the image and then it gets put into the web. So Lambda is pretty cool. You can't do nonstop coding because that's going to hurt a lot. But users can focus on coding without having to manage their servers because, again, Lambda is serverless. And you can pretty much just write and upload code into a zip file or a container image, and that code will be put into the Lambda function. It's run on a high availability infrastructure, which is infrastructure that can run continuously without interruptions. And thankfully, Lambda functions are able to perform administrative tasks such as maintenance over servers and the OS, autoscaling based on traffic or demand, and management, which can include things such as concurrency and capacity provisions. So again, the cloud is pretty secure, but the way that Lambda is used can be abused so that it's less secure. Oh, yeah, there's also some use cases for Lambda, such as web apps, machine learning, which you're able to pre-process the data before feeding it into a machine. You can also do a lot of data processing, such as triggering an event to process data or have real-time streaming data. It's also great for handling API backend requests. And like I said, Lambda can be abused. And one of those ways is an XXE injection or an XML external entity injection, which is pretty much manipulating the way that web apps process XML language or like an HTML file. So for instance, if you have a doc type file, you're able to put some like malicious things in there, and then that will run in the Lambda function. And that way attackers can gain access to any files that you might have or any dependencies that an application is able to access. Another vulnerability is a SQL injection, and this can occur if you have a database in your server. So we've talked about SQL injections before, but it's basically when malicious SQL statements are injected into a user input. And those statements are commonly put in the select queries where clause, and that allows the actors to gain sensitive information in your database. The final vulnerability is a distributed denial of service attack or a DDoS attack. And this is when a network is flooded with a large volume of requests using a botnet, which is like a network of computers or devices that each have at least one bot on them that runs those requests. And that leaves endpoint devices unable to function properly. This is terrible for companies because it disrupts services, which means they have little to no productivity time. And that can be costly because time is money. And this also exposes any vulnerabilities that a company might have, which leaves them open to other attacks.
Okay, so yeah, that is the end of the slides. We're done a little bit earlier. So, are there any questions about any of the services or anything in general that you might have about AWS? Yes, that's a great question. Um, I don't have an exact answer, but my thought process would be use a bucket to store a bunch of things. And sometimes like data is kind of referenced as a sea. So they might have just thought buckets, water. Um, but yeah, just a way of storage. Any others? Yes. It's a very original question that I'm sure came off the top of your head. Yeah, so AWS comes with a lot of ways actually to create a high availability solution. Um, this kind of leads more into more technical or networking, but basically a VPC or virtual private cloud, I believe. Um, you could place a bunch of resources or instances inside of this, and you could use these things called load balancers, which basically balance the network load of requests to a specific service. So this basically negates one server or instance being overloaded by a bunch of traffic at once, um, which also leads into another way of AWS handling a dynamic amount of requests. So let's say you own a Christmas decoration business or store. So obviously, in the middle of the summer, um, you're not going to be getting a ton of requests. So you could actually scale down the resources in AWS, which A, saves you a lot of money, and B, let's say in the busier season, like the winter coming up, you could actually scale up your resources. So let's say um, Christmas Eve is your busiest day of web traffic that you have. Hopefully, you have that data stored somewhere, so you know that. Um, then you could ramp up your resources, or also if you don't have that data saved or that data saved somewhere, it can dynamically scale itself through AWS. Um, yeah, that's just one or two examples there. You can also spread or duplicate your instances or resources across different availability zones or regions. This helps not only serve like redundancy, so let's say one goes down, the next one will cover up in a different region. Um, it also improves latency. So let's say, for example, you have a website in the US West 1 region, which is, I don't know, somewhere in California, I think. And then um, all those users, obviously, who are in California are going to get served that information a lot faster than, let's say, someone in like Virginia. So I hope that answered your question. Okay. Um, Let me see. I might be able to pull up an example of AWS if I don't have to sign in. Ah, yes, I can. Before we cover our workshop a little bit more. So, combining my two interests of hockey and AWS. So recently, AWS have kind of collaborated with the NHL, um, and they came up with something called Edge. Yeah, great name again. So basically, it's a way of streaming um, data into the cloud, but not just visual data. So basically, if I remember correctly, they put some sort of trackers or something to collect data in the players' helmets, I believe. So a lot of location and um like I think there's one in the puck also. So you could kind of see if you click on the edge goal visualizer. So you could kind of see each player or dot move around, and this is the exact position that they were in when they scored the goal. So it's pretty cool how AWS could be used for like statistical or like location data and how fast and seamless it could kind of stream just into your web browser. That one was kind of weird since it was off a face-off. Here, we'll do this one again. So you can see some more motion. Wow, very cool. Okay. Okay, and then just yeah, some of like the permissions or services that we covered in here might sound or might have sounded a little intimidating, but if you join us on Friday, we're gonna have a pretty yeah, yeah, I was gonna say that. Pretty guided and low level introduction on how you could abuse some of these misconfigurations or vulnerabilities that we covered in this slide or in these slides. So yeah, feel free to come down and sign in, please.
Hey, I got a question.
Yes.
I dropped in the Zoom chat. Do you want me to speak it out loud or?
Yes, speak it for me, Dylan.
Oh, wow, that's crazy. All right. So, hypothetically speaking, in a different world, in a different life, I like to sell wrenches and anvils. You think AWS would be a good hosting solution for that?
Yeah, of course. As someone who has personally purchased a wrench, coincidentally, off an AWS service, I think it works pretty well.
Hmm. All right. Yeah. I also got this. It might be an irrational fear, but I got this feeling that someone might try to steal or just purchase millions of inventory without actually paying. Do you think that's possible? Can AWS protect me from that?
Going back to, as we said, how a lot of the cloud services are kind of dependent on how you configure them. If you configure a purchasing portal uh, with no way to confirm a payment, uh, yeah, I don't think AWS can really help you there. That's uh,
Are you
that's more
saying it's
of
a skill issue? Are you saying I'm bad at coding?
yes.
Oh, okay. Thanks.
Yeah, no problem. All right, any last questions? Yes, Bill. Hmm. Um, yeah, so the question is, are there any like built-in services that kind of help you find misconfigurations or vulnerabilities? I believe there is. I forget the name of it off the top of my head, but if it's not directly a scanner, I believe there are frameworks or kind of templates that are already kind of try to try to be configured securely. Um, yeah, when it comes to that, or uh, there are also a few just public or yeah, publicly available, just like scanners on GitHub or something. If you want to like actively scan and look for the misconfigurations that way, you could definitely do that. Um, so yeah, yeah. So according to Google here, there's a few. Once again, going back to the wonderfully named services such as Astra Security. Oh, I guess these aren't all services. Okay. Okay. The main one is AWS Inspector. I think that one sounds familiar. And then an example of the third party open source solution would be a Scout Suite. All right. Last questions? All right. Thank you for coming.